What is a logarithm? So let's start off by relating this to something that you probably already understand, and it will be quite related. You'll see that in a minute. But let's talk about the fact that 3 squared is equal to 9, and how this is effectively just another way of saying that square root 9 is equal to 3. Well, why do those say the same thing? Well, because square root 9, by definition, what we mean by square root 9 is the number which, when squared, is 9. If it helps, you can think about this in an equation. So square root 9 is the number that satisfies this equation. And you can see that this equation is satisfied by 3, right? When 3 is squared, you get 9. So that's why, 3 squared equals 9 tells us that square root 9 is 3. These are basically the same fact, just stated in different language. Well, the only way that a logarithm is different from all of that is that instead of making x the base and saying what when squared equals 9, we now make x the exponent and ask the question, what can you raise 3 to the power of so that the result is 9, right? So the only shift is going from the base to the exponent. That's the only difference between a logarithm and a root. So again, it's the same idea, just stated in different language. The fact that 3 squared is equal to 9 then tells us that log base 3, right, because we're saying that the base here is 3. 3 is the base of the exponent. So when we take log base 3 of 9, we're asking for what is the exponent, and in this particular case, it is 2. So this shows you how you can compute a logarithm. You're just looking for what is the exponent that makes the equation work out. So whenever you learn something, you want to make sure that you exercise it. So let's use this idea, this definition of what the logarithm is, to compute some logs. Let's take log base 5 of 25. Of course, the numbers are chosen so that things will work out cleanly. But this is equal to 2. Why is it equal to 2? Because 2 is the exponent. Of course, we're taking the base to be 5, but with that base, making the exponent 2 gets you the target number, this 25. So the logarithm is equal to 2 because 2 is the exponent. Let's do it again. Log base 3 of 81. I claim it's equal to 4. How do I know it's equal to 4? Well, I'm always going to write the base as 3, and if I make the exponent 4, I get the target number 81. So the logarithm is the exponent, which is 4. In fact, we can get a little abstract, right? We can say that if we take any number, call it b, right? I think b has to be a positive number, but whatever, let's not worry about the details there. Let's talk about log base b of b. I claim that that's always equal to 1. How do I know that? Well, if you take the base b and write the exponent of 1, then you get b, because anything to the power 1 is always just equal to itself. So we get this kind of abstract law that log base b of b, no matter what b is always equal to 1.